screen down and probably fix the date. Today is the 8th, all day long. You will notice on Schoology, 3.5 and 3.6 are a combined assignment. There are a couple problems in there that you really got to read carefully. So, hear me when I say this. Slow yourself down, write down your work, and read your problems carefully. If you're confused, ask myself, ask a peer. You can even ask somebody in Accelerated 7. They just did that lesson yesterday, so they're working through the same homework. So, if you need help, ask for help. You looking for 3.3, Justin?
Yeah.
I only had a couple extra yesterday, so I don't know how many there really. You looking for 3.3 also? Here, I'll give you the one out of my folder.
Thank you.
You're welcome. You get my last one. So you were here yesterday, right?
Yes.
So where are your notes?
It's probably in my room because I did a bunch of stuff in my room.
So I'm hoping, I'm going to assume that your notes were out of your binder because you were doing your homework and using them for your homework. Don't correct me if I'm wrong. And that's why you don't have them today. Let's just go with that, okay? That you were using your notes for your homework, and that's why you don't have them. That will help me sleep at night. So, simple interest. One last, two problems left. But one last time or day, that we're talking about simple interest. So who can remind us what simple interest is? We better go back 2 days. If we don't know this, we better restart this lesson. If nobody can explain simple interest, I have failed. Anthony? What about, so what is balance? So balance is my total amount of money in the account. Xavier?
Simple interest is it's the one thing that you're getting added into the account. Interest.
Yeah, so interest is money being added onto your account based off of what?
So you can go to a bank, put in a balance to your accounts.
Okay.
And the bank will offer you a certain percentage.
There it
so
is.
much will be added on yearly.
Boom. So it's a percentage of what you put in that every year, if you use your part formula over there, that just gives you 1 year worth of interest, and then you can multiply by how many years. So we found out how much Alex and Mia had, right? We had solved for after 8 months. Did we? Yes, somebody please, because I'm not sure. So Alex, I believe his balance had come out to be $3,000. And Mia's balance was $3,050. So now we have to answer after 16 months. So again, if you're on this side of the room, do Alex first. If you're on this side of the room, find Mia's balance first after 16 months. Be careful, and you guys can work with each other on this. Be careful that this is not in years. It's not given to you in years. You gotta make it years. Yeah, to use it, it needs years, but it's not currently in years. Well, it's 1 year and an extra 4 months. So is 4 months a third of the year? 4 out of, think about it, 4 out of what? How many months total? So is 4/12 a third? Yeah. So you're absolutely correct. Coffee. So Shane, no Shane today? No Shane today. He was not, well, apparently, if he's not here. I hope if he was on the bus and now he's not here, that's an issue. Jaheim What do I do to my 16 months in order to use it in my formula here? Well, be careful with same exact number. I got to make it. What does my time need to be in order to use it? To use this? Yeah, in this case, it's going to be a fraction because what label has to be attached to my time? Abby? Years. So since this has to be years, whichever of these times that I'm looking at, whether I look at Alex or me, it doesn't matter. I set that up with the number of months. What do I do with it?
You put it under 12.
Ooh, over 12.
Over
You divide
12.
it by 12.
And that would be a year.
Casey, did you have a question?
Oh, no.
So, when you go to type this in your calculator, you can type this all in together, but you need to be careful. You do 2950 multiplication symbol, 400ths multiplication symbol, then open parentheses, 16 divided by 12, close parentheses. You gotta have those parentheses. Otherwise, things get a little weird. So the interest that Alex earned comes out to be, Casey?
I did this right. It would be 157.3.
Well, financial form, 30 cents. So be careful with the 0.3. And the interest earned from Mia is... Hayden? Yeah, but cards are pointless if people don't have it calculated. That's the problem. So here's the thing. You guys have up here how much interest that they earned in 8 months, and Mia earned $50. If I leave my money in the account for twice as long, what should happen to my interest? Yeah, it should do the same thing as my time. If my time doubles, my interest doubles. She now makes $100. So Mia's balance is $3,100. Alex's balance is now $3,157.30. So now Alex actually has more money. How has Alex now passed Mia? CJ? His interest rate is higher. Alex is going to make more money more quickly because his interest rate is better. Any questions on how that all worked? All right, the last thing we need to wrap up here is solving for the whole, or in this case, solving for the principal. So, your friend comes to you bragging, right? Friends like to brag. Says, dude, I made $5.51. That's like enough for a taco. I made $5.51 in only 9 months. I get it. This doesn't sound that lucrative, but when you start investing lots of money, you can make lots of money. So we know how much he made. We know the interest amount. We know the time, kind of. I need to convert that to years, but that's okay. I'll get there. And we know his interest rate. We need to calculate how much money he must have put in there. And let's say he offers you, if you can figure out how much money I invested, I'll give you my interest. Maybe your friend's a big math nerd. So, work with partners or whoever's close to you. Set up your equation, your I equals P times R times T. Plug in what you know. Try to solve for the principal. As soon as I write this out, I will be around to help if needed.
I did that and it just came out with this.
Question.
Oh, yeah, guys.
It looks like you're turning around with a pencil in your hand, not looking at the sheet. It's okay if you guys are working here. You've got to be working. So the biggest thing to get down first is write down your formula. So there's no numbers, no just I equals P times R times T. Then we start filling in what we know. So just work left, right. Do we know how much interest that they have? So fill that in. Then equals, do we know the principal? No, that's what we're trying to solve, so leave that as it. Then times, fill in the rate that you know. And then times, fill in the time that you know, but be careful because we got to convert it to years, so it's actually going to be in the form of a fraction. So start with your formula. I equals P times R times T. Guys, no matter what with these problems, and I'm just going to start marking progressings. When there's no work on tests, I'm just going to start marking progressings. I'm not going to grade it right or wrong. I'm just going to mark it progressing. You need to set up the problem. Over and over and over again, I say, please write the formula, and yet when you go to do it on your own, you immediately start writing numbers. Stop it. You have to start with a formula so you know what you're doing. If you have yet to do it, write this on your paper. You're probably writing down here, but I don't have space. Like, I'm not going to bend like that. It doesn't work well anymore. So start with your basic formula, because if nothing else, at least you've written something down. At least you've made an attempt. And if I stop right there, at least I know that you know the formula. You might not know how to solve this, but at least I know you know the formula. Then fill in what we know. Just work through it. Do I know the amount of interest earned? Yeah, it was the 551. So we start to fill this in. 551. Do I know the amount we started with? No, that's what the problem's asking me. How much is the principal? Leave that as a P. Do I know the rate at which the account is getting? Yeah. 0.03. Do I know my time? Casey? What do I put in here for my time? 9 divided by 12. So now, do what you can. Stop trying to jump right to the answer. In my formula, I can multiply these numbers together. I can't use the P because I don't know what it is, but I can multiply these two numbers. So we do that. $5.51 equals P times whatever this product was. Well, it's 0.03 times. This is really 3/4. Xavier, what do we get?
0.0225.
Then, this is the tricky part, we want to isolate or get alone our principal value. CJ? Yeah, we divide by this value that we want to get rid of. That's what we're dividing by on both sides. Now this becomes 1. Any number divided by itself is 1. So 1p is just p. And my answer, Hayden? And rounded to the nearest dollar then. Not nearest $10, nearest dollar. So what was it? It was 240. 244 point what? So would that round up or stay 244? So this should be 245. Questions? A lot of people, as I walked around, were saying that they were confused. So what questions do we have about this process? The smartest people ask the most questions. This doesn't mean like, I'm not trying to call out that if you don't ask questions, I'm just saying the way you get smarter is by asking questions. Because to convert months, so if I start with 9 months, MOS is your abbreviation for months, and I just set it up over 1, like any number I can set over 1. To get that to have a label of years, I need to cancel out the months, so I put it on bottom, and I need to put in years. So the months will cancel with the months, but I need a conversion factor here. I need numbers to make this work. Well, 1 year is 12 months, and there we go. We just get 9 over 12 for my years. Other question? If it's months, if it's days, then this would be set up 1 year over 365 days, so we would divide by 365. And that is shown in your intro, just up the page a little bit, like in the middle of the page, if this would ever capture. Right here. So this intro. I would, if I was you guys, I would probably put a star next to this, because anytime you have to convert with a unit of time, you just convert by that conversion factor. With months, it's 12 months. All right, let's move on into 3.5. So you are going to have the opportunity next year, and actually we might give you the opportunity this year, to participate in science fair. Science fair is awesome. I love science fair. It's a great time to practice experimenting and write like hypotheses, and then actually really science fair is a great like leaping off point for lots of careers involving science. So the Mythbusters are basically like science fair. All they do is experiment things, test things, whatever viewers ask them or whatever questions they're pondering. So on the Mythbusters, one episode that was really interesting, at least to me, was that they were researching, do plants feel? Like, can a plant feel? How did this end up here? And they did this by measuring height of a plant. So, when they came to look at the plant, you got to know, where did it start? Like, what was its height the last time we looked at it? Abby, can you put that away, please? And then, how much did it grow by? So, if we got taller, that would be an increase. If we got shorter, that would be a decrease. But instead of talking in just inches or just centimeters or anything like that, using percentages is more fair. Because let's say we're doing a science fair project, and we go to Home Depot and buy 30 lilies or daisies or whatever flower you like. I didn't even think about your name until you perked up. So, do you think that all 30 flowers that I buy at Home Depot are going to be the same height when I buy them? No, that is very, very improbable, because it's nature. Things grow like however they want to. So, by looking at percent change, it makes everything more even though they didn't all start at the same height. When I look at the percent changes, it's now comparing how much did it grow compared to where it was, or how much did it not grow, or how much did it weaken. So, let's say we're using Miracle Grow. Round 1, we're using Miracle Grow. We're growing these plants. So, please give me your focus. If it was 10 centimeters and it grew to 15, what did it grow by? 5 centimeters. What was its old height? 10 centimeters. So to set up the percent, sorry, I didn't put them back in the right place. They're actually right here. To figure out the percent, it's always part divided by whole. But in this case, it's change over original, or what it was. Now, be careful with the word original here. I would, if I was you, write what it was. Or you could write previous. Because it's not always like the original. And that matters when we go look at the decrease. So, any questions on percent increase? Because percent decrease kind of changes things around a tiny bit. The amount of increase over what it was, do the division, multiply by 100, get to your percent form. When we look at the decrease, so my plant was growing, we're doing well. Now I decide I'm going to water my plant with Coca-Cola. So, based on your reaction, I'm guessing you can all predict, it does not go very well. My plant was 20 centimeters tall. It had grown to a great 20 centimeters. Then I watered it with Coca-Cola for a week, and I came back, and it had wilted down to 15 centimeters. Wait.
How do you know that it decreases the Coca-Cola?
I'm making up a story. And Coca-Cola has all kinds of things that are not good for plants. Yeah, or humans. CJ.
But what about the plant in the back?
So that's what it was, like, at the beginning of the week, and here's where it is now. It's just kind of showing both images. So, in the interactive lesson thing that I used to use, it had a little video that had the plant and then it wilted. So you could see this is where it was, this is where it is now. So, this is why I cautioned you about using the word original. Once you're done melting, get yourself back in your desk like a real person. The percent decrease now becomes the amount it decreased by, and they still use the word original quantity, which I don't love, because that's not the original, really. It's just the last checkpoint that I had. So, are we kind of with me on why I would caution you about overthinking original? Just think about previous, like what it was. Cool? Questions? So, decreases by 5. It had been 20. I get the fraction, multiply by 100. I get my percent form. Any questions on our setup here for solving percent increase, percent decrease? All right, so let's try this. Essentially, and this is why I wrote this here, essentially our equation that I would like you to use is change over previous is really the equation you want to use. And then, of course, times 100 to get to percent form. Change over previous times 100. So, Mr. Smith has you guys doing a challenge. Every month, he's having you document how many of certain workouts you can do. So, first month, you just got back to school, kind of lazy, you did 15 push-ups. The next month, you're like, man, I got this. I got way more. You do 30. So we want to figure out what is that, what is that as a percent change? So we know it's percent increase because you got better. Justin?
100%.
How?
So if your first record is 15, you're going up when they double it, then think of 15 as half, 30 as a whole. So.
Ooh, be careful. I was with you until you said 15's half and 30's the whole. Because you told me we did 100% increase, right?
Yeah.
If I use 15 and 30 as like 15 over 30, that gives me 50%.
30's 100% now.
Ooh, so that's now my current. So the previous was also 15. And when I have an increase of 15 over a previous of 15, we really get 1, which is really 100%. So a 100% increase. What does it mean to have a 100% increase? What's another way that we could say that? Andrew?
Double your previous.
Yeah. So if we increase by 100%, another way we could say that is we actually doubled. We went up by as much as I had originally, increased by 100%, or we just doubled. So now, solve the crunches on your own for that percent change. Yeah. What do you mean? So the big thing we're looking at is it's the change over what we had done previously, or what we, like, where we started. I went up by 15. With me there. I started with 15. So these are two different 15s. Okay. So to do my crunches, again, it's change over original or change over previous. So, Grace, what is my change here? What was my original? What percent is 14? I'll put that down. 14 over 100. Anything over 100 is that percent. So we get a 14% increase. Questions on calculating this percent increase. Try the frog problem on your own. We are doing research on a frog. We measure when it's sitting down. It measures end-to-end 51 millimeters. It jumps. We slow-mo or whatever so that we can measure when it's all spread out. It's 89 millimeters. What's the percent change in the frog's body length? You guys can work partners or people close to you, whatever you want. Questions in Spanish? You don't have to. Give me a math question. Decide if I can hold on to the pen or not. Outside of school, sure. In school, it's a district policy that you guys have to use Mr. or Mrs. Actually, my band teacher in high school had told us to call him Barry because that was his first name, and he got in trouble. Like, they called him to the office, and they were like, Barry, you can't have your kids calling you Barry. It's a respect issue. So he's like, no, but my kids respect me. They can call me Barry and still respect me. And they're like, it's you gotta have them call you Mister. So the next day in band, he was like, hey guys, from now on, call me Mr. Barry. So still today, even though I'm like 27 years old, still today, and when I see him, I'm like, hey, Mr. Barry. Because that's just like, that's how we think of him. CJ? Right? I mean, there is that argument. But you guys are kids. We're adults. It's a respect thing that you refer to somebody by their like surname or their proper name. So you just use the Mr. Be respectful. No, never mind. We're moving on. So, Flynn, when you set this up and you look for the change on top, what'd you get for the change in the frog's length? Can you? Who calculated this? Anyone do the subtraction? What'd you get? 38 on top. So we set up the change divided by the original. When I do that division and then multiply by 100, I will get 75%. Anyone verify for me? Yeah? 75%. They say find the approximate percent increase. So if you want to cut off the decimals and round it, you can. Yeah, because it'd be 74.5%, so you can round it up to 75. On the moon, which, by the way, those conspiracy theorists that like believe that we didn't go to the moon, we went there. There's trash up there that proves that we were there. I'm serious. Like, we left debris there. Part of it was intentional. There is a device that they left on the moon that when you shine a laser at it, it reflects, and the moon's surface is not reflective at all. So they alluded to this in a Big Bang Theory episode, but this is real. So you can, at a certain time, and you can track it, like you can do the math to figure out when, shoot a laser at the moon, and it bounces back, and you can like catch it, like you can use a laser receiver, and you can make that bounce to prove, hey, that stuff up there, we left it there. I mean, they left like space junk, like things that I think the rover might even still be up there. Or,
Space
like, I mean, think about it right now on Mars. We don't have any people there, but we have crap up there. Like, we have rovers and like we have things like that all over the place. We're just kind of polluting the solar system. And actually, the amount of satellites above us, there's so much like trash in space. Like satellites that are still floating around that don't do anything anymore. They're just still there. So one of the shows that I watch or listen to is called Star Talk. It's got Neil deGrasse Tyson, which you've talked about in Connection some. One of the things they talked about was it's going to become an issue that there's too much trash in space, and when we go to try to travel in space, you got to watch out for the trash. So eventually they're going to launch a mission to go collect the trash in space, which I think is kind of really cool. Yeah. They'll bring it back to Earth probably. Yeah, no, they'll just or if you push it out of the Earth's orbit, it just goes elsewhere. But it's stuck in Earth's orbit. So we would have to shove it far enough away to get out of our gravitational pull. But to get back to what we're actually talking about. On the moon, if you were not in a spacesuit and you jumped, you would go way too high. Like freak you out, poop your spacesuit high. So you guys understand, spacesuits are weighted down. So if you put on a spacesuit on Earth, you feel crazy heavy because the whole thing is weighted. Because a 154-pound person on the moon would only weigh 25.5 pounds. Now this goes back to a scientific principle. Mass is preserved. The person's size has not changed. But the weight is relative to gravity. So this could help you impress Kabilo. Mass stays the same. Mass is preserved. Weight is relative. Weight adapts to where you are. There's actually a slight variance in weight on the Earth because it's not perfectly spherical. If you're closer to the center of the Earth or further away, like up on a mountaintop, there's a slight, very, very minor difference in weight. By what percent does the astronaut's weight decrease? So to find this, Joe, let's talk through this together. I know you didn't have any time to solve this on your own, but what do we want for our numerator? Not numbers. What is our numerator going to represent? The what? Guys, shh. Yeah, we're doing percent change still. Ooh, that's our denominator. Our numerator is going to be the change. So to figure that out, well, 154 minus the 25.5, and of course you could do this in your calculator. The previous is which? Really? The 154. You were on Earth, then you went to the moon, and we know the previous because it tells me weight decrease, which means my previous value has to be more. So, what's my change then when I do the subtraction? We get, go ahead. And you get? So guys, when you go to the moon, and in your life you might, who knows? When you go to the moon, your weight decreases, goes down by 83%. So you end up weighing 17% of your normal weight. Essentially, take like a fifth of you. Take like your right leg, and that's like how much you would weigh on the moon. That's crazy. Justin? Reason through that with me. So what does it mean to be a negative? Like a lack of quantity, right? Like you owe some. So like, could something weigh negative? You can't go past zero when we're talking about like distant or like. So black holes kind of break the rules of physics. So that bringing in black holes into an argument, you kind of like that's like the atomic bomb of like it doesn't. You can't argue that because it's a totally different thing.
If you didn't owe mass, then like you're sucking away.
Like eating the mass, yeah. But you can't actually like weigh a black hole Because, like, can you set it on a scale? Like, that's... So, that's... Now, mass is a different sort of idea. Like, the mass of a black hole, but you got to bring that up with Kabilo, because that goes beyond my realm of expertise. So, that state up north that we don't like to talk about. So, now, this is really, really interesting, especially since it's an election day. Right, Atticus? Any idea what I just said? You have any idea what I said before that? Because you're turning around talking with Jack? So, turn this way. Pay attention. If one of you guys needs to move, move. If you can't control yourselves, I'm going to have to. I don't like doing that. So, control yourselves. Please focus. That state up north has lost enough population between the 2000 census and the 2010 census that they actually had to give up a representative. So when we vote, and this is what we talk about with, like, this is a presidential year versus non, there's elections every single year. So that's why I keep joking when you guys are like, who'd you vote for? I voted for a lot of people, because there were like 57 issues on the ballot. A lot of them were like elected officials, some of them were bonds and levies and things like that. Part of what you vote for is the representatives for the House of Representatives, which is determined by percentages. Whatever percent of the population, you get that percent of representatives. Anyone know the total amount of representatives in the House? 100 for the Senate. That's easy. Every state gets 2. But the House, oh, it's 436. What, Anthony? I think it's 435, if it's still the same. Should be 435, I believe. So, it is complicated. So, hold up. If we look at percent decrease in representation for Michigan, what, Mr. Braun, was the change in their representation? You don't know. They went from 15 down to 14.
Alright. Do the work. Alright, so 15 minus 14. 14 is 1. 1 over 15. And times 100. Illuminati. 6.666666. Oh my god.
So let's round that. So, that state up north ended up with a value of... So, about, if we round, 7% less representation, which can make a difference when you think about, like, the House is deciding things for the whole nation, and especially if you followed anything about, like, the water crisis in Flint, or the Detroit, like, jobs crisis, that, like, there's just not enough work up there. They need representation, and they lost 7% of it because their population went down. Or the rest of the nation population went up, and Michigan did not, but I think it's more likely that their population went down. Now when we look at estimation, don't touch those calculators. Estimation is when we just make the math as easy as possible so we can solve it in our head. So, if I'm looking for the accurate, I'd look for change over original. My change from 11 to 20, Abby, help me out here. My change from 11 to 20 would be?
Would that be like? I'm gonna guess is that no.
If it was 11 and it's now 20, how many centimeters did it grow by?
Oh, it grew by
There we
Good
go.
morning, Summer Weiler. Please come to the office. Summer
So hold
Weiler
up.
to the office,
This
please.
would be
Thank you.
9 over 11. But that's kind of hard to work with. Because 11's... Now, if you remember your 11ths rule, it's easy to work with. So, if you remember your division by 11, anyone remember it? What do you multiply the numerator by? If we divide by 11, we actually multiply the numerator by 9. So this would end up being...
99.
No, what's 9 times 9? 81. So it would be 0.81 repeating forever, or approximately 81%. But I'd have to remember that rule. So forget about that. Let's make life easy. No rules to remember. How could I make this division a lot easier? CJ? Yeah, just make this 10 instead of 11. It was 11 centimeters. We'll say it was 10. So if I make this 9 over 10, that becomes what percentage? 90. And that math was way easy. Where the actual would be about 82%. But if we're just approximating, 90 is close enough. It grew by about 90%. Yeah, we'll wrap it there for today. We will pick this up and do 3-6 tomorrow. Your test is Thursday and Friday for Chapter 2. Chapter 2 test Thursday and Friday. Have a great day, guys. I know, that's why it's Thursday and Friday. And even if you don't get done on Friday, it's okay. We'll give you time on Monday.